Hello everyone. For this video, I'm going to talk about inverse trigonometric functions. This is the last topic included in our subject pre-calculus. So let's start. So we have the following objectives. Letter A, illustrate the domain and range of the inverse trigonometric functions. Letter B, evaluate the inverse trigonometric expressions. And C, solve situational problems involving inverse trigonometric functions. Which I believe that prior to watching this video, you have already knowledge about the 6 trigonometric functions, right? And aside from that, based on your discussion in general mathematics, you know about one-to-one functions and inverse functions. To recall about one-to-one functions, let us consider this definition that a function is said to be one-to-one if for each x in the domain of the function f, there exists exactly one y in the range of the function f such that f of x is equal to y. That means for each unique element in the domain, they are paired to exactly or to each unique element in the range of the given function. So let us consider the given example here. Find the inverse of f of x equals 2x. And recall the process of finding the inverse of a function. First, we are going to replace f of x by y. That is, we change f of x to y. Thus, we'll have now y equals 2x. Second step, we will interchange literally the variables x and y. Thus, this will be x equals to y. And for the third step, we will solve for y in terms of x, right? That is, we can only solve for y in this case if we divide both sides by 2. Okay, dividing both sides by 2 will get y equals x over 2. Lastly, we will replace y by f inverse of x, our notation for inverse function. Thus, the inverse of the given function f is equal to x over 2. Essentially, inverse functions sequentially undo anything on x in the original function. So that is why for f of x equals 2x, we do the process of undoing the operations and we get 2 over x. So the inverse process of multiplication is division. Okay, now let us try to find the inverse of y equals sine x. Let's proceed with sine function. Let's understand how are we going to find the inverse of this trigonometric function. So let's say we have the function y equals sine x. So following the steps that we had a while ago for f of x equals 2x, we will also replace f of x by y, which is in this case, we have already here y equals sine x. Second step, we will interchange x and y variable. Thus, we'll have x equals sine y. And since we need to solve for y in this case, we cannot simply say that we need to divide both sides by sin. Okay, so we cannot divide the term sin for this example. Okay, and for us to solve for the inverse of this function, we need to take the inverse of both sides of this equation. That is, we'll have inverse sine of x is equal to inverse sine of sine y. This will cancel out the sign operating on y. Thus, we get y equals inverse sine x, meaning the inverse of the given sine function is the inverse sine function, which is y equals inverse sine of x. Okay, so that is about the inverse sine function. But we must take note that the inverse sine of x is not equal to 1 over sine x. Okay? But if we had the quantity or the expression sine x raised to negative 1, they are equal to 1 over sine x. But recall that 1 over sine x is equal to cosecant x, right? Okay, so you have to be very careful with the notation for inverse sine function, which I believed, okay, you can easily recognize this one, right? In terms of the angle and the value of the given function, let's say if you have y equals sine x, our ordinary sine function, okay, we are going to plug in angle at this part, okay, dyan sa x variable for us to generate, okay, if you plug in an angle, this y will generate a sine value. Okay? That means the operator in this case is the sine itself. But for the inverse sine function, for y equals inverse sine of x, we are going to plug in valid sine value, which is your variable x at this point. So valid sine value to generate an angle. Okay, so that we can find the angle for this one, which is the inverse process of the situation above. Okay, so I hope that this is clear to our students or to you viewers. Okay, now let us consider the graph of sine function, because recall that a function can be illustrated as a table of values, graph, or a formula or an equation. Okay, so at this point, we have the illustration for the graph of sine function. And based on the previous lessons, the domain of this sine function is the set of all real numbers, because this is continuous both to the left and to the right of the Cartesian plane. Also, a function must pass the horizontal line test to have an inverse function. But based on this illustration, sine function is not one-to-one, right? So with this, we will restrict the domain of this sine function, okay, from negative half pi to positive half pi, and that is the only way for us to check that or to verify that this is now a one-to-one function. Thus, it has now an inverse, but its range will be the same. We have from -1 to +1 still. Okay, so in terms of the inverse function, the domain will be the range, and then the range of this sine x will be the domain of the inverse sine function. So we'll have now our illustration, okay, for the inverse sine function, or it is also known as arc sine. Okay, so y equals arc sine x is the same with y equals inverse sine x. For cosine, we also have inverse cosine or arc cosine. For tangent, we also have arc tangent. For cotangent, arc cotangent, and so on. Okay, so this means we have the inverse of the given sine function. So based on this illustration, we need to show that the inverse of the function is reflected on the equation, or the line rather, y equals x, which is represented by this blue curve. Okay, now the domain will now be the allowed values for sine from -1 to +1, while its range, these are the angles. Okay, kindly take note of this, because later on, as we proceed with the examples, you always have to recall the domain and range of this inverse sine function. That is from positive, or from -pi/2 to pi/2. So we have these characteristics of the sine function. Okay, the restricted inverse sine function. Now we proceed with the first example about inverse sine function. So let us try to find the exact value of inverse sine of square root of 3/2. So we are going to use this unit circle for us to easily answer this problem. Especially if you don't have your calculator with you, it would be better that you refer to your circular functions. Okay? At this point, if you let the given expression be equal to y, we'll have y equals inverse sine of square root of 3/2. If you are going to write this in terms of its sine function, not the inverse sine, we'll have sine y equals square root of 3 over 2. So how are we going to explain this one, this situation right here? We just take sine of both sides of the equation. So we get sine y and then sine of inverse sine of square root of 3 over 2. So we can cancel out the operating sine function for us to solve for square root of 3 over 2. If you're going to refer this unit circle, for us to solve the angle that generates square root of 3 over 2 for the sine function, so the angle that gives a sine of square root of 3 over 2 is this part. Okay? We have pi over 3 or 60 degrees. If that is the angle that gives sine of square root of 3 over 2, thus y will be equal to pi over 3. Also, inverse sine of square root of 3 over 2 is pi over 3. That is for our first example. However, some of you might ask that aside from pi over 3, for 2 pi over 3, it will also generate sine, okay, sine of square root of 3 over 2, right? Because if you're going to check, the y-coordinate of this point is square root of 3 over 2 for angle 2 pi over 3. Okay, so let's explain this one. Why do we have this kind of situation that instead of saying aside from pi over 3, we can also consider, or why did we not consider 2 pi over 3 as the one of the possible answer for inverse sine of square root of 3 over 2? So actually, aside from 2 pi over 3 and pi over 3, there are other values or other angle that will generate square root of 3 over 2 for the sine function. So let's say if you take a 1 revolution, okay, and the terminal will be from square root of or from pi over 3, let's just say 420 degrees, that is more, if I'm not mistaken, 8 pi over 3, will also have 1/2 square root of 3 over 2. So aside from pi over 3, we can also say that we have 2 pi over 3, we have 8 pi over 3, and most probably 14 pi over 3. Okay, so all of this, okay, these four angles will generate square root of 3 over 2. Okay, but again, okay, why do we only consider this pi over 3? Even in your calculator, if you're going to recheck your calculator, if you input square root inverse sine of square root of 3 over 2, that will give you pi over 3 only. It will not display these four other and the rest of the other values that will generate inverse sine of square root of 3 over 2. Okay, so how are we going to use our calculator to check this one? So in your calculator, although I don't have my emulator in our screen, okay, so I hope you can still view this one. For your calculator, if you have this ClassWiz or some other calculators that are Casio or some other brands will do, you have above sin, cos, and tan, we have the notation for inverse sine, okay, inverse cosine, and inverse tangent. So all you have to do to display the inverse functions by clicking Shift key, okay, this Shift key, and followed by the trigonometric function. Let's say inverse sine, you'll get the, or shift sine, you'll get the inverse function. Okay, so you can try this on your calculator. But take note, this is only limited to the first three trigonometric functions. Okay, so later we'll continue and also discuss the rest of the trigonometric functions. The reason behind this phenomena that we have right here is, if you're going to recall, the sine of any angle lies from -1 to +1 always. So if we consider the unit circle with radius 1, which is this illustration right here and take the sign of any number around the unit circle, it can only give you a number maximum of 1 and a minimum of -1. So maximum of 1, okay, we are referring to this sign, okay, and this point right here, this -1 here. So if we are to find the inverse of, let's say, -2, -3, or +2, +3, or any number greater than 1 or lower than 1, that would be impossible for this unit circle. That will give you math error in your calculator. So, the input for the inverse sine function must be from -1 to +1 only. And in the output for that inverse function will be from -π/2 to +π/2 only. Same with cosine and tangent and the rest of the trigonometric functions. The value itself will only be limited from the domain and range of that inverse function. So that's why we will not consider 2π/3, 8π/3, 14π/3, and the rest of the angles for lower than -1 and higher than +1. We are only going to base our answer between this range. Okay, let's proceed to our next example. So we need to find sine or the exact value of sine arc sine -1/2, meaning we have the composite function or the composition of two expressions, sine and this inverse sine of -1/2. At this point, for us to find the exact value of this expression or of this inverse function, we need to find first the value of arc sine -1/2. Looking at again this unit circle, will have 11π/6, or if you get the negative angle, we'll have -π/6. We get the coterminal angle to this one, the negative coterminal angle of this value. Since we need to find a composite function for sine and arc sine -1/2, after finding the arc sine of -1/2 rather, okay, we'll have to take the sine of both sides of this equation. Thus, we'll have sine of arc sine of -1/2 is equal to sine of -π/6. Sine of -π/6, if you're going to check, so sine of negative of the angle -π/6 will give you again -1/2, meaning the exact value of the given expression is -1/2. Okay, so again, we only based our solution in our unit circle. You can also verify that one using your calculator. So first, click sine, after which you are going to click shift followed by sign again and then input -1/2, and that will display -1/2. Just make sure that unit, okay, of the angle is in radian. Although what we have here is -1/2, when you input or use a degree as the unit of measure, that will also give you -1/2. And I'll show you the easiest way later on how are we going to find the composite of this kind of expression.